Hello, everybody. Wow, that is a background. I will not lie to you. That is an awesome background. Uh, Hello, everybody. It's Brian. It is Wednesday, and I am here at my world headquarters. Been, you know, it's one of those things. I do so much. I don't want to say work, but it's like by the time I realize it's time to stream, I've done a lot of stuff at my job and just futzing around with vibe coding that I'm like I'm kind of done for the day. Um, I really need to kind of take the vibe coding stuff and kind of build on it, or build some things that might be interesting to continue on with. I've really been okay. Stop with the fucking YouTube thing. I've been trying to finalize what might be Project Darkly, which is my RAG, my remote retrieval augmented generator. But every time I think I'm done, there's always this little, I don't want to call it improvement, but there's always this little thing that pops up that's like, man, I wish it was fixed, or oh, there's a new thing now. So um, I think the last time I streamed, I talked about something called dockling. Let me pull up. I think there we go. Pull up dockling. What do we got going on here? Uh, this is part of it. So there's something called there's a VLM option. So one of the things that I've been working on. So dockling, uh, VLM hugging face. So I'm trying to. One, I started over again with regards to the architecture. Uh, I was having issues with Docker, and I'm actually getting rid of Docker in terms of the solution, because there are a good number of problems with using Docker in macOS for the Virtua, was it Virt IOFS? Virt IOFS, which is the shared file system that Docker uses. And because we already had issues with Docker, and I need some background music here. So what's my chill hop essential? There we go. All right, so we'll listen to the Centrals 2026 there. Make sure this doesn't blast people out. I can turn that down a little bit. Bring that up just a little bit so everybody can get a little background music as well. Good groove, chill out, essentials, awesome stuff. Oh, okay. Oh, turn that down to 240. I don't really need the video at all, but it is what it is. So some of the documents, some of the PDFs that I use are quite large, and the quality is different for some of them, as you can see here. And I've made some changes. I made some updates. I don't think that makes any difference. One thing I'm in love with is the colorblind bits. I've added a specific style sheet for colorblindedness, and that. Oh, hold on. Oh, okay, there we go. As you can see, I've made the upgrade to PostgreSQL from SQLite, because I had issues with timeouts and with file locking issues. SQLite is a lot of things, but it's not performant for multiple operations. And we were having issues where some of the workers were having issues with that. Oh, cool. Progressive test. Okay. So I've been putzing around with this. I actually had blown this away and started over again in the time that, since we last chatted, since I last showed kind of slideshow of what's going on. I've actually made so many changes that it's probably a completely different system now. We've kept Dockling. We've removed SQLite for Postgres. We have upgraded. No, we haven't upgraded the embedding model yet. We're still using Olama. We're still using Docker, but we're going to go to OrbStack here in the next, probably tonight when I do this. The reason for that is the Virtue IO FS stuff. So Virtue IOFS is a file system that allows virtual machines to access the directory locally, which is how you do things like bind mounts or how Docker mounts file systems from the OS. And one of the things I learned early on was that Docker doesn't allow for native access in OS X. So if you want to use GPS heavy applications or things that take advantage of Metal, which is the GPU API or system that Mac OS uses, you're shit out of luck. So I started moving a few things off natively. So Olama and Dockling are actually running natively on bare metal because you can only virtualize so much without losing any kind of performance hit. So one of the other things that I do is I have a folder. So let me pull that folder. All right, so we have a folder that I call PDF ingest, and that's where I put the PDFs or documents. It doesn't have to be PDFs; it can be Markdown, it can be docx, it can be PPT files. The idea is it will take these files in this directory and process them accordingly. As you can see, some of them are in here. Some of these are documents of certain type, certain file systems, certain role-playing game systems, because it's not security. It could easily be a security system for like policies and procedures and documents for analyzing those things and searching them by inference, but that's not what I'm using for. The problem came from some of the documents I have are PDFs that are basically somebody's taken a book and scanned it and then opened another page and scanned it and then opened up another page and saved it. And then so 294 pages of that document is really just PDF JPEG files. So a bunch of JPEGs or PNGs that are in a folder. So some of them are not as good quality as others. Others are digital born, which are, let's see, what would be good? Oh, here. So like the Pathfinder book here. So this book was made digitally, right? It was built and created for digital content, natively built in something like an Adobe, some methods. So you can tell it's got a nice layout. It's easily done. And then you have. Oh yeah, here we go. Yes, this would be one. So, for instance, this is made back in old-timey days. This is one for an ancient D&D setting called Greyhawk. You can tell that it looks like it was made. You can actually see what looks like there might be. This might be a booklet or something, or it might have been a larger page, but it almost looks like you can see the staples where they exist in this system. But you can see that it's definitely not more professional typeface, typesetting, fonts, etc. It even has different fonts, right? So you can definitely tell it's a bit. This is obviously newer than the other one was. This one was made quite, 1983. So not to date myself, but I was about 5 years old when this came out. I am 48 now, so you can still buy these books on like Drive-Thru RPG, but they're coming in this format. They're not coming in a nice OCR format. So to be able to pull them in and be able to do things like make queries on them, I need the text, right? And I need the content that it comes with. So this one is particularly complicated because it's not a friendly font. So you need a vision model to be able to just basically take a digital snapshot and then pull that data as it is. Anyway, back to my original bit here. So, uh, Dockling system. Oh, wait. Yeah, there we go. Dockling.ai. This is the system that I built. They have two versions of this. They have the Dockling library, which is a bunch of Python files and stuff like that that you can use to convert messy documents into structured and simplifying, processing of your documents. But they also have the Dockling server version, which um, is an entire. There it is. Running Dockling as an API service. And so I upgraded to that because what I wanted was telemetry. Every time something would go wrong with version 2, which is the one I showed you last time I streamed, because I was like, oh, these are all the cool things we did. I started analyzing and thinking about it, and I was like, every time something goes wrong, I have to tell Claude, hey, fix this thing, or restart this thing, or whatever. And I was like, that is not a good system. If I had to, if I had to go and tell somebody every time something went down as a web app, oh, go restart this system, or go, bounce Nginx, or go bounce, this service. That's not a resilient system. That is not a well-made system. This should be, I don't want to say self-healing, but it should be a bit more resilient to doing processing of files, that kind of thing. So one of the things that I thought of was, well, we need an orchestrator. We need something that is an overseer that will watch from on high all of the things that are going on. In this case, whether it be the Dockling system, or whether it be the SQLite system, and the file system over here where it's pulling those PDFs into Dockling, which is then putting the chunks for indexing into SQLite, or for the indexer, which is then taking them and putting them into Quadrant, which we need something that is going to monitor, gather telemetry, gather that information, and be able to make it available to me as the person running this to go, oh, something is wrong. Please, address that, or please fix that. And I was like, I don't want to have to keep asking Claude, hey, what's wrong with this thing? Let's fix it. What do I need to do? That kind of thing. Or, running command line arguments to get this thing to fix. Anyway. So I set up Dockling because the idea of the API services, I'll be able to call it, I'll be able to get status, there's some runtime options, there's configuring of the web server, you'll be able to pull down various data from the endpoints. So basically what I did was I included a SIM inside of my RAG, which allows me to also export the log files as a JSON, allow me to search for whichever directory is being worked on at that time. I can search by, if I have multiple workers, I can tell it to look for whatever is being ran there for that. So I can see where certain aspects of the book went wrong, like the quadrant mismatch here, that kind of thing. And it gives me different levels. Like if I want to see the warning messages or the info messages for Greyhawk, or see, it takes a little while to do that. So I can see that I'm having quadrant mismatches for World of Greyhawk or City of Greyhawk, which are two different ones. I can see warnings that tell me the job has been reclaimed from a dead worker. Now that is, that's that. Okay, I think it works if you use dark. So okay, I'll have to fix that. So during the processing of City of Greyhawk.pdf, in this case, a job was reclaimed from a dead worker. So I noticed that the worker was dead in this case, and the orchestrator actually did his job. And Claude calls it a reaper, in fact, by basically reclaiming the dead worker. It's a reaper in this case. I didn't make that joke. It did it for me, which is kind of funny. So Uh, yeah, I've pretty much rebuilt this whole damn thing from scratch. Let me see if I can find. So one of the other things I thought was kind of cool was I have installed the draw.io MCP, and I have asked it to create. Okay, so this was the format. Do I still have the SQLite in here? Or is this the okay SQLite? Okay, this is not the updated version. Let's see if I can go find the latest document here. The one thing I really like about here it is current document process. No, I don't think that's it either. Let's see. Oh, no, that's the SQLite database. Okay, I can have it refresh that. So I've got draw.io up. New generate a new data flow and process diagram in draw.io. So right now it's doing something in the background. You may hear the fan on my MacBook running. It is not the first time I've heard that in the past couple of days. The one thing that I do kind of wish I had was I don't want to say a fatter chassis, but some kind of method by which I could um, process these locally. I do have my think centers, which I'm thinking about repurposing, but they're all CPU, so the output would be far less performant in this case. So I was building that. I was all ready to go. So a lot of this is still the same for the most part. The fast API query service, the embedding using BGEM3. Yes, allow the MCP draw.io. When you use draw.io for this, it tells you your changes will be lost. You just say cancel. Okay, so we have. All right, so you see our PostgreSQL here. We've got a lot of data going to it. It is our documents, our chunks, our job events. It does a lot of work. It's a bit more performant than SQLite ever would have been. We had a lot of issues with file locks or the ability of the SQLite to keep up with what was going on, which makes sense. It was just kind of meant to be a key value pair. It wasn't necessarily meant to be something that was doing a bunch of stuff like the Postgres or a proper database was. So we have workers that are doing what they're supposed to do. So we have an extract worker, another extract worker, and an embed worker. The reason we have three workers, two of which are extract and one is an embed, is because Dockling will not handle more than two work streams at a time. That is one of the hard limits of the Docker server, or the Dockling server aspect. And the embedded server quadrant will only handle one at a time. So even if you had 5 embed workers, it would be processing one chunk, and then it would move to another book and process another chunk, and then move to another book and process another chunk. So 3 of those books would take 3 times as long. It's very inefficient. Ideally, what you would want to do is have potentially multiple machines running quadrants, or have one server running quadrant and having a bunch of servers being able to run the embedding process and then sending those chunks to quadrant. I'm not sure I need to go that far yet. So, yes, read. And an ingestion sequence diagram. I'm just not feeling it right now. I don't know why, but all right. So we have our diagram there. Where is the? Oh, this is the one we don't need anymore. Okay, so it's creating a sequence diagram. Uh, when I started on version 3 of Darkly, I realized that everything was kind of working independently on its own. The version 1 was I found out that the various PDF implementations that I was using, like PyMu PDF or PDF Mux, or when I moved to Dockling, the information that you get from PyMu PDF or PDF Mux was not informing the process down further. So I would run PyMu PDX and it would tell me something, but then there'd be a second aspect that would be extracting the data from the PDF and would have to basically start over again analyzing the PDF and maybe getting a different result than what PyMu PDF or PDF Mux were getting. And nothing was the data wasn't feeding into making a better product in this case. So version 2 was okay. Let's get rid of PyMu PDF or keep PyMu PDF in terms of being able to figure out level of confidence or whether or not the document is a scanned PDF versus a digital made PDF. And oh yeah, PyMu PDF would also rip out all the images and store those as well for later on when you want to maybe add those back in when you're viewing the file, or if it's like you're looking at the markdown, it will give you those image files that you can pull in. Oh, there we go. And I don't know if this is how developers work. With this internal process, I find myself trying to work through this whole process. And I'm not a developer by trade, which is probably why it's only taken me so long to actually, start playing around with developing applications and tools because I didn't have the wherewithal to do any of this stuff. Um, oh, wait, something's happening here. Maybe the other thing is done. Uh, So when I built version 2 and I was looking at building on version 3, I used the sequence document to go, okay, okay. So, son of a bitch, what is going on with that? It may be that we have to use the old slower version, even though VLM will work for some things, but VLM won't work for larger files. So that's kind of interesting. Yeah, very interesting. Yeah, we've got a standard error narrowing down 70. Each batch adds 10 pages and complete in 25 minutes total, faster if it fails early. Okay, cool. So I was using these diagrams to help me figure out where things were going wrong. And I've actually started using these at work where I was asking people questions about things. So we have the dashboard, which runs on port 8080. It shows the various components that you would need to understand and work with. So we have our PostgreSQL database, we have our orchestrator, we have the background scan thread, which this is not exactly to scale. This is because I'm testing the VLM as well. So there's a few things that have been added to the, where is it? Dashboard. So uh, you can see what I've got going on here with this. I have my Postgres database. I have the dashboard, which runs on port 8080. Probably a bit overkill to run its own instance, but it could be that way. Quadrant 1, which is the one quadrant, there's a query server. Here's an embed server, the workers, Olama, and the orchestrator, which is supposed to be the brains of the joint, right? And then quadrant init 1, which these two are not running right now because they warm up quadrant, they warm up the model. I'm still a little in the dark on why you need to warm up the model, but it is what it is. It allows me to come in and go, okay, I see these things happening. I see these things happening. Here's the extract phase, the file discovery phase. So we have the folders. When I drop a file into that PDF ingest folder, then there's a watchdog or there's something that actually watches and looks for new files or updated files in this folder, and then we'll pull them in and store them for processing. So when you see what's going. Actually, I've skipped these because I don't want them to process while we're doing the testing because well, one, I'm also streaming now, so I don't want to use any more resources than I already have, and I'm already testing um, the running of the system right now. But I could run all of these, and they would run in order according to certain aspects. So um, I was trying to work through that various process, and I don't want to say I've been having problems. It was actually working really well up until I found the Hugging Face thing. And actually, I may leave this alone, but the idea is for version 3.5. There is a specific Hugging Face model that is a multimodal image text to text model engineered for efficient document conservation. And I found this by going to the Dockling GitHub, and it's a 258 or 258 million, 258 meg, 258 meg maybe. Builds upon previous architecture. It has two modifications. It replaces the vision encoder with a different model, substitutes a language model as well. VLM means that it will run natively on OS X. That's what I've been trying to find. I've been trying to find a faster method because the dockling is what takes so long right now. I'll give you an example here. Scroll down so I can show you some of the ones here that have ran. So let's the Underdark one here. So um, status is done, 161 pages. Okay, where is, man, it doesn't, I took that out because I was like, I don't need it. Shit, that sucks. Uh, Login beads to include uh, OCR time spent. I don't know who that is. Dockling time spent when we removed the recent activity section. We lost some metrics to show how quickly documents were ingested. And you add those metrics back. I think I've got enough screenshots that I've taken because sometimes I will, I have to give it screenshots to tell it. That's not it. Where is it? There we go. Okay, so preview. So to show you, and if it doesn't know what I'm talking about, I want to have this for available. So it'll show you it took 1 minute 12 seconds to run. The OCR took 49 seconds. The embedding and indexing took 23 seconds. I actually had last night a couple of like 50 page files that took like 5 seconds to run because they were digital made. So all it had to do was pull the text out of the text layers and make that happen. So it took 1 minute 12 seconds to run this 98 page document. As you can see, it was a digital. It was either a scanned PDF that somebody had added a text to OCR layer, or it was a bot. It was a digital made PDF, and that is probably a homebrew. Actually, I think this is the Prince of Undeath. I think was a homebrew document or something like that. So it was already digital made. But I'm missing this like time it took, OCR and embedding. So if it gives me any lip, I'll just give this list again. Oh yeah. Okay. So copy. One thing I find helpful with the model is to be able to do screenshots to tell it, okay, this is what I'm seeing. This is what I need you to fix. And example of what we used to have. Or methods previously and context AIN7. Sometimes I'll actually expand out the thing and read what it is saying to me whenever it's going through and doing this stuff. Uh, yeah, when the activity section was removed, allows per book timing, visibility, add these back. Yeah, and the total duration, phase break, exactly, 100%. That's exactly what I wanted to do. Because I have sometimes problems explaining what I want. A picture is literally worth 1,000 words. Um, so I have number of screenshots where um, sometimes I will just copy paste them in because I have my screenshot link, but other times I'll forget and I'll have to add certain things in there. So yeah, that's good. Yeah, good stuff. Uh, okay, close that. Actually, I'd go back to PDF ingest there. Uh, yeah, so I wanted that. It knows what I'm wanting, so that's good. So I can close that as well. Close that. There we go. Make AIN7 P3. Okay. So what I'm having it do right now is, like I said, I'm having it test this because anything I can do to make Dockland faster would be ideal, right? Uh, I don't, I have, like I said, as I've said in several streams, several thousand of these PDFs, and I want to make sure that I'm not spending all my time chunking this stuff up. I've already had to start over again because uh, Quadrant went from like 1.10 dot something to 1.19 something, and in doing so, it added certain what they call sparse versus dense chunks, which meant that I had to, I tried saving it, but they were like, no, this is a different format, which was kind of sucky for Quadrant folks to do. And I ended up having to rebuild it from scratch. The other end of this would be to move to something like PG vector, which apparently would give me less capabilities, which is an open source vector similarity search for Postgres. But I'm already using PostgreSQL for some of the logging and the worker stuff, so having yet another PostgreSQL box probably is not going to be a huge deal if I have to go that route. But it will affect search, which, to be honest, I haven't tried search in V3 yet. I don't even know if it'll actually work. Let's see. Search. So what I had originally was less of a chatbot interaction. I wanted to kind of replace Claude with whatever we were using for work here. So um, oh, okay. So that it gave me the answers, but it won't give me it gave me places to find that information in there, but it won't give me answers. And actually, I don't even know if that's correct or not. Oh yeah, okay. So you can't click on it, and it will tell you things about. It will tell you where dwarves exist in the book, which is kind of interesting. Uh, and then, of course, you see there are some text issues, which there's not going to be any vision system that is going to give you 100% perfect recreation. So if you really want like byte for byte completed, uh, being able to reproduce the PDF doc from your RAG is going to be nigh impossible. I'm assuming if you had more standardized documents, like typical white papers or academic papers, where you're using a solid serif font, you've got your kerning in place, you have white on black, nothing fancy, super vanilla type, or a policy or something like that. If you wanted to use a rag for like that, the ingestion process, as I have seen, would be far simpler, and it's probably why. Studio LM and some of those can say, "Oh yeah, here's a rag," and it's like, "Yeah, that's great." I have a bit more complicated use case here. So, um, yeah. So, let's see. So that one was even wrong. So I'm going to have to, once we figure out this thing, and this may actually just be a nothing burger, and I'll just have to tell it to get rid of the VLM. But ideally, we'll be able to process these in the order in which they were received, um, and then plan that accordingly. I've been learning about loops, which is what I read an article from Anthropic about how one of the directors there or something, he doesn't even build anymore. He just creates loops all day, which is something that you end up you seeing a lot of in this case with being able to do iterative process over time. Like I'm looping right now with version 2 and then version 3 and then version 3.5, which will be, whether I stay on Docker or OrbStack or something like that. I'm actually going to go to OrbStack. I'm not going to continue using Docker um, because the PDF ingest folder exists on my bare metal box. I run into issues where it times out. It just says, "Yeah, I'm just going to go to sleep. I'm just going," you know, or I made the horrible mistake, and you see that here. So the reason I had these skipped is because I moved all of these files into this folder immediately, right, at one time. So I had I think I had like 25 in here. I think I put 25 files in here, and um, you move them into PDF ingest, but um, they don't. That doesn't necessarily mean they immediately go into Docker. They're kind of like, say you got a fire hose, right? So your fire hose is how your normal file system will work from bare metal to bare metal to bare metal. If I took and copied everything from PDF ingest to PDF docs, which has nothing in it right now, you're going to see that is very much faster. So let's say I did this and paste these 21 files. So boom, done. It's there. They're there, right? So what happens with PDF ingest is I've copied a bunch of files in here. It takes a few minutes for them to, I don't want to say replicate, but for virtual IOFS to make them available inside Docker because of performance issues. So yeah, um, it's not perfect, and it will cause some lag to the point where I was like, I couldn't tell the system, okay, once you see a new file or once you see a bunch of new files, then run this stuff, or run it every 30 seconds, check every 30 seconds for new files, and then run that on that file, because I could copy a 60 meg file in here. It may take so many seconds to get it available fully in Docker's bind volume or named volume there. So add to it the fact that Docker doesn't allow direct access to the GPU. Just a bunch of bullshit. And I was like, okay, well, there's enough strikes here against using Docker for disk I/O or GPU access or something. You know what? Actually, let me double check. I don't know if stack OSX GPU access. Yeah, see, GPU accelerator and containers, direct GPU are not available for containers in OrbStack. Okay, so the GPU thing is still going to be a problem, right? I can't use metal pass-through is what I'm looking for the models for various aspects of that. OrbStack or any other Docker environment, Mac OS, because OS X lacks native containerization and relies on Apple's virtualization framework. Containers must run inside a Linux VM with CPU fallback. Um, I think, and according to so what was it? Yeah, so they did mention this at this year's WWDC. So it was a tool for creating and running Linux containers using virtual machines optimized on Mac Silicon. I'm still not sure if these OCI compatible containers will allow for GPU and metal access. Um, but I can only be so choosy. So there's going to be some point where I'm going to have I need to get rid of Virtuo FS. That's one of the bigger issues that I'm having with lockouts or with issues with throughput there. So I'm just it is what it is. So yes. Anyway, uh, let's see where are we at. What's the status of uh, VLM? I actually, I had still running no output yet, working through. Tell us if the failure's in 61 to 51 to 60 range. I'll report as soon as it finishes. I've been trying to get it to add not concurrency, but if it's doing a per page examination of the process, what I would like it to do would be like, okay, you're going to get to page 59 and then something bad happens, right? I wanted to save that content all the way from 1 to 59, even if it is it's not perfect, but I don't lose 59 pages worth of processing. And then when it restarts, it will resume at where it fails. And the idea would be, well, if it fails at 59, the orchestrator will be like, I've recognized that there's a failure. I need to restart that worker on that book that hasn't been completed yet. And oh, yeah, let's start it over where it exited. So let's say the crash or whatever the worker wasn't perfect, but let's say it got to page 50. Let's say that the data got sent to the Postgres SQL server and we got up to page 56. I'm still 56 pages in. Even if I lost 3 pages, it's going to resume at page 56 or 57 and it will continue on, that kind of thing. So I'm trying to build resiliency in there. I'm trying to build, it said self-healing. That's the idea. I want the orchestrator to heal, if you will, or to be able to recognize that there's a problem, restart services that I'm unable to monitor myself. Because what I don't want to do is have to go to Claude and go, hey, I noticed the current book is busted, has been sitting for 2 hours, for 3 hours. What's the deal? That's not helpful. The idea is it should be automated. It should be able to respond to those issues and not with AI. The code should be there that allows it to handle those things. So when I run into these issues, I tell it to investigate, log the root cause, and create a beads work item for that. And it does pretty good. I mean, I don't know which model I'm on right now. I think I might be on Haiku, which I could switch. I'm running a bit on the cheap side here for this thing. Oh no, I'm on Sonnet right now. Okay. Um, I ask it to do that. I ask it to investigate and then come up with a root cause solution, and then build the beads work item, and then put the root cause in there, and then what the suggested fix would be, instead of it going, just fix it or whatever. I find that has been very helpful. That it helps me with a certain process, with a certain idea in mind, how I'm going to work through that. Tell me what, and asking it to be specific, asking it to debate me on fixes. Like if I wanted to do something, tell me what I'm doing wrong there. Um, I have noticed that a lot of people at work, when I talk with folks, I ask them how they interact with the system, and I'm beginning to understand why people think, oh, I need to be on Opus and I need to be on. Oh, no, 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 don't do that. No, 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 don't do that. No, 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 don't do that. Sonic, go back to Sonic. Yeah, my bad. Yes, yes, yes. Shut up. I'm sorry. I love you. I love you, Claude. Um, I understand why people are like, oh, Fable's going to be out and it's going to be awesome because I've actually had people tell me I expect to only have to tell the AI to do that thing one time, and they expect perfection from having to write out a 3,000 page or 3,000 line request to this thing fully formed, and when the output of that file is pretty much the thing they want. And I'm like, that's no different than programming. It's you're having to spend a ton of time writing out a huge query to get exactly what you want. I actually, I don't, yeah, I wouldn't call it. It's not, it's not that I enjoy it, but it's like it allows me to have a bit more interaction with the process and the prog and moving forward here. So what we got going on? Okay, so I also don't give global access forever for any of the commands that I run. Usually, just for each session, I tell it if I know I'm going to get something that is um, uh, if it's something that's not destructive, I usually tell it, yeah, go ahead for the session. So, oh, what was that? What was that? What was that? Started testing 1 through 60, but it never logged a result. The process crashed. It was killed before writing the outcome. The background tests completed exit 0, but the child process was killed, likely out of memory error. Oh. VLM accumulates state per page, and with 60 plus pages of a dense scanned PDF, metal GPU memory or system RAM gets exhausted. Oh, huh. Interesting. Yeah, show logs. One of the things I wanted to do was have those logs because Dockling doesn't have logs. So I went to Docs. I did Dockling serve because it has endpoints, it has status, it has health, it has all these things. The Python scripts that originally I created with V1 and V2 didn't really have a lot of resolution or not tell me, hey, it failed. Why did it fail? That kind of thing. And I would have, Claude would have to go in and read the script and to go, oh, let me monitor what's going on, and I'll watch the output or whatever this thing. And I was like, yeah, I don't want to have to do that every time. So you need to add some logging for various activities. So a lot of try except kind of things where it would log, those error messages. Creating test cases to go, okay, we need to test this before we implement it. Is this going to work as we did? When I started with V3, the first thing I said was, well, we need some test harnesses or test cases to be able to simulate taking a document all the way through the pipeline, which it did. And it was working great, as you can see all the books that I put in there. And then I found the Hugging Face model, and I was like, oh, I should give this a try and see if this will make it faster. And before I started streaming today, it said, oh, yeah, it looks like it'll be anywhere between 2 to 7 times faster if the PDF is digitally made. As you can see, what I've got going on right now, it's not working so well. Oh, D-message. Ooh, something killed real good, didn't it? Oh, okay. So now I'm plugging into the startup messages for the various systems. Can't confirm out of memory from logs patterns for 50 pages works 60 plus consistently crashes without writing output. Process killed mid-execution. This is almost certainly a memory limit. The VLM holds all page states in memory during conversion. Around 50 to 60 pages of dense scanned content exhausts available metal or system memory. Huh. But yeah, see, as you can see, the one psionic book, which was 3 pages, very fast, minus OGL boilerplate, that was kind of interesting as well. It was the VLM model that I was using would get rid of legalese and boilerplate, so like the OGL stuff. I don't need 500 versions of that in my database, clogging up my database with OGL content. I believe in the OGL. I think it should be in there, but it's taking up chunks and index and whatever that is not going to be useful for me. I'm not going to be asking it for OGL questions or anything like that. I can download a copy of the OGL if I wanted to. The new VLM model is actually smart enough to not put the last page and a half of OGL stuff in the document. So that's also time saved if it's going to cost me 10 to 20 seconds every time to OCR that stuff. Sort of deals with a scan, 36 pages, 2.7 times faster, better than standard on scan text. Arcane Power is the big one. Clean stat blocks and tables. That was the digital one. So the scan one's causing problems. Planescape was a 294-page document. It did run for 50 pages, no problem. 7 seconds per page is actually quite good. When I was running Planescape in version 2, it took 2.5 hours or better to run. So it was about a minute a page, a minute and a half a page. So there's real performance ask here. If I could get this to work past page 60. So what I'm wondering is, okay, so it's asking me for adoption. We need to split large PDF scanned files into about 40-page chunks before feeding into VLM. Do you want me to do? Yes. Yes. Please log that as F61B. But also, would it be possible to dump that memory? I'm assuming index. I'm assuming chunks, indexed chunks. Wait, chunks, yeah. Assuming those are chunks to be ingested to Postgres on a regular basis, so we don't have to split PDF prior to scanning. Because what I'm wanting it to do is, let's say it does 10 pages or 15 pages, then there would be some kind of secondary Python script or something like that that would take what's already in memory and dump it directly to the Postgres SQL, or if we can make it so that it will pipe that directly to whatever answer it gives me here. Because if we could just set up something so that it would pipe it directly to Postgres without storing in memory, is there a reason it needs to be stored in memory? The fact that we're exhausting we're getting out of memory issues, why can't we just store that directly to the database? Wait, the log file just updated 1 through 60 actually succeeded. 401 seconds, now it's testing 1 through 70. The earlier run must have, what? The earlier run must have been killed by the background task timeout, not OOM. Let me check. 1 through 60 passed. The earlier crashes background tasks shell wrapper exiting, not the Python process. The VLM test is still running. Okay. Testing pages 63, 65, 67. First results. To your question about flushing to PG instead of splitting, yes, that's exactly the right approach. Memory accumulates inside doclinks document convert, which holds the entire document in memory. If we process page range batches, say 40 at a time, flush the chunks to PG after each batch and release the converter, the memory stays bounded. Ha ha ha. Uh, it's a memory allocation issue that hits the wall around 60 pages of scanned content. This confirms the chunked conversion approach is the right fix. Stop. In process and batches of 40 to 50 pages, flush to PG, release memory continue. It'll update to 61 F61B. Final VLM memory walls at 60 to 63 pages for scanned content. Digital PDFs are fine at 160 plus pages. Um, could go one step further and instead of pushing to memory, directly writing to PG database. Please debate me on the merits of that. I sometimes have to remind it to not be a yes man. Um, my suggestion may not be the best one. It may think, oh, he's a dumbass, but I'm going to say yes to him anyway because he's the boss. I want him to tell me no. I want him to tell me yes. Good question. Let me think about the approaches. Option A. All right, scroll that down. All right. Let me think through the approaches. Motherfucker, Jesus. Process 40 pages, hold 40 pages of docling document in memory, then chunk and write out to PG in one shot. Memory 40 pages worth, save, proven at 60. Problem with that is if I've got a bunch of things going, let's say I've got Blender running or I've got some, I'm also doing DaVinci Resolve or whatever, I may not have enough memory in GPU to output 60 pages before it crashes. So one reason I'm asking to flush directly to PG without storing in memory so that I'm not filling up memory with pages like that. One page at a time, minimal, no ceiling at all. 500-page scan book works the same as a 3-page one. Option B is clearly better if Dockling's Vim pipeline supports per-page streaming. Question is, does convert yield pages incrementally, or does it buffer the entire document internally before returning? Yes. Well, I mean, if it doesn't yield pages incrementally and does indeed buffer the entire document internally before returning, option A or B will not work, period, because unless we do originally what it said, where we chunk these into 30 or 40 pages at a time. So it's not going to be perfect, but we'll see. You got the original option of splitting PDF into 40-page chunks to process, then no, actually that's what option A is, but the only concern is that if I'm doing other things that might take up a lot of GPU, video editing, Blender, etc., 40 pages may end up being OOM as well, right? Yeah, it was measured on the idle system. You're running Final Cut or Blender with metal GPU memory already allocated. Ceiling drops, maybe 30 pages, maybe 20. Batch size that works today crashes tomorrow, depending on what else is running. Option B eliminates this entirely. Well, your option B is predicated on understanding if you can do per page dumps of the convert memory. And I have a feeling the timeout So I have a timeout for like, because in version 1 and 2, Planescape was taking upwards of, and then the workers would die. So after 2 hours, I was having it kill the worker because obviously it wasn't finishing, or there was some kind of error right there with it unloading itself from memory or what have you. So I had it set like after 2 hours it would kill the servers and then start over again, or try to attempt to start over again. Um, yeah, we need to verify that. Checking the Vim pipeline for per page processing. Yes, please. Checking per page process internals. I'm learning a lot about document generation and retrieval and processing than I ever thought I would, to be honest. Because I don't want to say I have to verify what it's saying or doing, but yeah, I'm finding myself I'm having myself verify or at least think critically about various things. So yeah, I'm running into various aspects of that. So let me see. Yes, allow pipeline feeds. The other thing I found out is that Mac OS's version of Python is still like 3.9 or some shit, and the one at Homebrew is 3.14. So I've had to tell it to use the Homebrew version of that, and I actually uninstalled command line tools and Xcode because don't need it. Don't need it. I'll just homebrew everything up. And actually, one of the things that I was thinking about doing, since I've had this box for over a year, there's a lot of cruft on it right now, and it probably could do with a refresh. So I may end up having to reinstall the OS at some point in the near future, which fills me with dread. Not because I am okay, not because I've never reinstalled an OS on Mac before, or on Windows, or on Linux, or whatever. But I will forget something, or we'll have to spend time reconfiguring shit to make that happen. No temp split is needed. Each call processes only those pages, builds a fresh conversion result, and releases memory when the results are discarded. This is option B without touching dockling internals. It's public API. Well, fucking A, man. That is the best of all things. Fantastic. So Convert has a page range parameter built in. Page start end 1 to indexed. So we can call. Okay, the one thing I want to understand is I don't want this thing stopping and starting dockling like 150 times. So what does it mean to do that? What kind of performance hit would we take by telling it to start on page 1, then start. Stop on page 1, then start on page 2, etc. Process 40 pages at a time. Oh, wait. Huh. Wait, so am I reading that right, where I could actually run 40 pages at a time? Not that would speed things up very greatly. So are you saying that we could process 40 pages at the same time? That would be interesting. I would actually give that a try. Right now, the reason I did the Planescape document was because in version 1 and 2 of Darkly, it was easily the most complicated fucking document that I had. And it is of an era, as you can see. Not that one. No. And I will tell you that I won't tell you that some or all of these are legitimately purchased. Here it is. So this is the document here. It's pretty iconic. I mean, when you see it, it's amazing. The artwork style and is very, very interesting. Um, this is obviously back in the day before, this is a manual of planes or something, the multiverse, if you will. So, the artwork is of a specific type. It's not, obviously not AI related. And there's almost art on every page. So you run into the complications of this, but it's one of those ones that's, it varies between one long, and then you have the more specific two-column output that you see in a lot of um, RPG books, pretty much 99% of them of a certain type. Um, and a lot of tables. Tables was the other thing that came a problem. If you use a typical OCR system that doesn't have vision in it, it'll just mangle these tables to hell. And actually, that was one of the things that I was concerned about, being able to read these accurately. And I mean, you've got freaking breaks in the page and weird stuff like that. So some of these pages have very little text on them, or a lot of. So it didn't have to be 294 pages. It could have been a lot less, but you run into all kinds of things like that. So. But yeah, this one was taking the original version 1 and version 2 Darkly systems several hours to process. And when I tell you my computer got warm, the computer's fan was on, and it was probably above about 105 degrees, which is massive for my MacBook, which I can normally, if I'm not processing books, I can easily run 2 streams on YouTube and actually edit video on DaVinci Resolve and render that at 4 to 8K resolution. No fans come on. So that just tells you how much GPU and CPU are being used by Docker to process these books. Almost no penalty. Batch all 3 at once. 30.7 seconds. 10.2 seconds a page. Per page, reuse container. 27.8 seconds. 9.3 seconds faster, but less memory pressure. Per page is essentially free, no meaningful performance penalty. The overhead stays loaded in MLX memory between calls when reusing the converter. When creating a new converter, each page adds only 1 second of overhead. To your question about processing 40 pages at a time, not simultaneously. Okay, right. So yeah, so I'm actually going to lose out here a little bit because the Dockling server, not the VLM model, Dockling server will actually handle 2 books at the same time. VLM will handle 1 page at a time sequentially. So I can set 1 book, but it'll only process 40 pages in 1 convert call. The difference is you just hold 40 pages of results in memory versus flushing after each page. Given these numbers, single page processing with converter reuse is the best approach. It's actually slightly faster than batching, less memory pressure, gives per page progress, and has 0 memory accumulation. It's also interesting, page 1 to 63 of Planescape just succeeded in your narrowing test, 622 seconds. The earlier crash may have been memory pressure from other processes. Well, and that makes sense. All right. So we need something that will peel off individual pages, track those pages. Let's talk. Let's chat more about what that single page processing would look like. Let's see how much more tokens I got here. So, okay, so I'm still good. So my usage, 1 hour and 1 minute, I've only used 30% of my stuff. So I need to really do something that's going to use a lot of stuff before my 5 hours is up. Um, oh, right. Uh, okay, my model use reset today, so I'm only using 4%. I've actually been butting up against like 95% on my weekly limit because obviously I'm burning a ton of tokens here. So um, very interesting. Okay, so what would that look like? Could you feed the book into the system, and then we have uh, service take page one. No, we need a service. What do you suggest that look like? That's like something is going to need to scan the PDF to tell you how many books, how many pages exist in the PDF. If there's no metadata, which I found that some of these books that are just 200 and some odd pages of JPEG files do not easily surface how many pages there are until they've been scanned by PyMu PDF or something like that. Um, are you able to take the scan telemetry from PyMu to get things like level of confidence, level of OCR confidence, page numbers, page count, and whether it's a scanned or digital made PDF, and influence the per page output from the VLM. Yeah, I love the thinking part. I actually enjoy this more than the response because then I can actually see what it's doing, how it's thinking. The user is asking about the full page design, et cetera, et cetera. So we use PyMu PDF for pre-scan, which is already working. Extract worker, instead of sending the whole PDF, docklink serve run VLM locally on each page. For each page, render to image, run VLM inference, parse the doc tags chunk, and then write to PG. Okay. And then it'll sum up later. But yeah, I actually like when it does this. I actually like to see what it's thinking and how it's thinking and how it arrives at its conclusions. So phase one per page, PyMu PDF, Scout, milliseconds per page, right? For touching VLM, PyMu does a fast per page scan. For each page, it extracts digital text layer, if any. That's why they said the digital made PDFs have layers of text. So it actually doesn't do OCR if it's a digital made file. A lot of the, right. So it'll just, grab all of that information. It's like, let me see that. So let me see. Homebrew. No. Homebrew. Home brewery, there it is. Home brewery. All right. So people make things on this site for content. So if you go into the vault, you can see what people are doing. So let's say I wanted to get something on melee feats. So here's a handful of feats. So somebody makes a nice, this is a whole website dedicated to creating what looks like a typical D20 source book or splat book or something like that. So let me see, this has one page. Here's updated feats and boons. Here you go. So this is a a 250 something page document. And they build this and it's made with style sheets and HTML. I could do the same thing with Claw if I wanted to, and just build it from scratch myself locally. And there's actually a plugin in VS Code that will help you out with that if you want to do that. There's no pictures in here, which I would want pictures, but ideally you save this as a PDF and you get the PDF as is. But you can also outsource. Get rid of that. It also only works in Chrome officially. So I can clone this to view. There we go. So here's the rendering for that. So I don't have to save to PDF. I can actually, this is all the text, right? So this would be very similar to the PDF. So you have the page, the PDF page, which is blank. They lay the text on this. It's almost like an HTML page. You take the style sheets, which then make it do, no, you have your div tags, you have your page here, you have your markup, so 3 hashtags, so that's a 3 header, header 3, header 3, and so you add the style sheet, and then you get this, right? And that's literally what it is. So when I get out of the way, source, clone to new, so I can do that. So what you're seeing here when I clone to new, because I do this quite a bit when folks can't actually, they'll make a mistake and try to shove too much on one page, so you'll end up with a third column on a page. You'll see like text on this side of the screen that pops up. So what you see here is that. So you see this here rendered over here on this side, which is kind of cool. And it's very much similar to how Adobe and them, I would imagine, do, where you've got your text, and it's like, for those of you of a certain age, you had Dreamweaver or Front Page from Microsoft. It's a what you see is what you get kind of editor in this case. So you can put in the formatting as you go along, or you can tell it to do certain things here, like I want to editor theme, or I want to add some bits in here to make a specific style type or something like that, or I want to make this a bold font or whatever. Go back. No. Okay. There we go. So we're back here again. You tell it how you're going to want it to look like over here in the render page. And anyway, when you save the PDF, the text layer is still there. It's just now you have the style sheet that you add to it, which let's see, where is it? Can I pull down the spreadsheet for the style sheet for this? Anyway, going too far afield. But anyway, so ideally that's what I'm hoping it'll do when it. So page 1, route each page based on its profile. Digital text, use PyMove PDF directly, skip BLM entirely, right? Milliseconds per page, perfect fidelity since text is already digital because we're just pulling the text layer out, right? It's also going to scan text, low character count, low image coverage. VLM processes this page 5 to 9 seconds per page. That's fantastic. This is where VLM shines, clean OCR output. Art illustration, so we'll render JPEG for clip embedding. That's something that the clip embedding is something I haven't done a lot with right now because I haven't pulled a lot of images. I don't really want to pull a lot of images because I don't really have a lot of use for them. Ideally, I'm okay with having the text, and then like if I wanted to click on something, I have the PDF, and it would automatically pull up the PDF on the page it's on, and I would be able to see things. I don't necessarily need the image. And in this case, image is, this image here. I don't necessarily need this image. I just need the text that it goes with. But if I wanted to see what a monster looked like, I can click on a link inside of the Markdown, and it should open the PDF page and go, okay, so, let's see if everybody's in like chainmail bikinis and shit. Okay, so let's say I wanted to see what a Zasotech was, or the Chaosman. I don't know what he looks like because I see the text. So I'm like, I want to see what this looks like. Click, give me a link to that page. Then I can just open the page and see, oh, this is what that person looks like going forward. Very distinct art style. Very impressive. Um, Interesting. Okay, so phase 3, per page, VLM, and immediate PG, right? For pages routed to VLM, render the page to image. PyPDF is less than 10 milliseconds. Converter.convert, source PDF, page range, PG to PG, or page to page, right? Parse doc tags and chunks, write chunks Postgres immediately, results discarded, memory freed, dashboard gets per page progress. Yes, that's another thing that I wanted because I'm sitting here when one of these runs and it's just sitting there waiting like 0 of 400 pages, and I'm like, and it's like until it's gotten past the extraction point, I got nothing, right? So I want that kind of telemetry to be able to show what is happening in Sitch. And the key insight: most RPG source books are mixed, maybe 60% digital text pages, headers, text rules, spell descriptions, 20% scanned complex pages, stats, tables, stat blocks, multi-column layouts, 20% art. On a 300-page book, 180 pages, PyMu PDF, direct instant, 60 pages VLF, a VLM inference, 9 seconds each, 9 minutes. That's not bad. I can actually live with that. At 60 pages, that means a 200-page document would still be in the range of about an hour. So 9 minutes instead of the current 45 minutes via doclink serve. And the PyMu PDF text pages get perfect extraction since the text layer is already there. PyMu PDF scout data travels with each page. OCR confidence, right? Okay, so I want that because this was going back to version 1 and then version 2. It was like PyMu PDF would give you all of these metrics, but then the next bit that I was using wouldn't use that information. And then I came to that conclusion. I was like, I'm really building 3 different pipelines to do something, and I'm going through all 3 of those pipelines and getting 3 different messages or 3 different issues. And so I didn't want that. That's hugely inefficient. VLM itself doesn't need these flags, just processes page images, but the routing layer uses them to decide whether to call the VLM at all. Okay, so that the PyMu PDF is less useful to VLM in this case, but it will help the orchestrator decide whether or not to invoke VLM or to, what stays the same. Orchestrator will still do document level pre-scan at discovery. Segmented extraction architecture still works. Segments equal page ranges. Chunks table, embed pipeline, quadrant, all-in change, dashboard progress, reporting actually better for page granularity. This is essentially what the original PDF quality profiler was trying to do, tier 1, tier 2, tier 3 routing. This goes back, PDF quality profiler was version 1 of this, what I call the PDF splitter. But with per page granularity and VLM as the tier 3 engine instead of PDF mux, the difference is now that we have a model that actually produces better output than the standard pipeline on scanned content. Do you want me to implement this on F61B? This is at the point where I'm like, yeah, I want to, but I want you to test first on the Planescape PDF. I've used the Planescape PDF enough, the one I just showed y'all, this one here, that it knows what I'm talking about when I say the Planescape PDF. And actually, I have another one in there that is a Planescape PDF, and it thought it was very similar. And I said, no, just look at the text. You can tell that they're 2 different files. So the Planescape campaign setting is the one I wanted to use, but there was also another Planescape one in here for something else. But yeah, I wanted to use the campaign setting on Planescape PDF. Do the per page test. Track the page updates and simulate a dump to PG SQL. Wow, that's impressive. The fan went off. That means nothing is happening right now. That was the other. That was the other way I knew that processes would be hung or no longer working when I was processing books because I was like, "Hey, what's going on? The fan quit running on my MacBook, so I know that the workers have hung or they've crashed and they're no longer processing books." It was like, oh, user noticed that the fan has stopped working, which means the CPU is not under or the GPU is not under load, and so you need to need to investigate what's going on there. So, uh, anybody got any questions? I don't know if anybody's even watching me. I don't even know if I care at this point. I'm just kind of interested in geeking out over something that I'm interested in. So, if anybody's ever done a RAG or an LLM, put a comment in that's below. What do you use for this? You know, the reason I'm doing this is I could pay Claude like $20 a book to process these in almost near perfect capability because Claude itself, the Claude that I'm using right here inside of VS Code, is a um, vision model. The problem is, let me pull that up because they're assholes. Um, I would have to. Where is it? No, that's not it. That is not it either. Count. Is that it? Billing. Oh, billing. Here we go. Um, you have to buy usage credits, and thankfully they block out the last, all but the last four digits of my credit card. Thank you, them. So that if I want to use the Vision SDK or the Claude SDK, I have to actually buy credits, which are different than the tokens, so that I can do that, um, which kind of sucks arse. And so it's just unfortunate. Which is why I was like, yeah, I want to do something local. I was like, as a last resort, because version one and version two sometimes would choke on some of these books. I was like, as a last resort, I would ask Claude to process that book for me, at a cost of, I think I told it if I had 5,000 books and you had to process them for me, it said it would be somewhere in the range of $400 to $950, and I was like, oh. Because I've already paid for the book, I shouldn't have to pay for processing it again. I buy all these books legitimately, and I don't want to have to pay for them again. So yeah. Okay. So no, I don't want to smoke test on the first 20 pages. All right, give it a shot. I wanted to process the whole book. I want to see how long that would actually do. Um, because what I'll probably do is shut off the dockling, and I'll just say turn that off. Take the VLM and move it into into the workflow. So, demote dockling server, promote VLM, and then interesting. The first 20 pages are classified as 14 digital text plus 6 art, 0 scanned. Ooh. Pymo PDF found enough text on those pages to classify them as digital. VLM was never needed. 20 pages processed in 9.6 seconds. That is a lie. But this is a scanned book. The text Pymo PDF found might be a pre-existing OCR layer. That is not something I expected to hear. That is interesting. Because I put Pymo PDF in at the first part of this for scanning the PDFs to gather that forensic information. I wouldn't even know how to tell if I could pull the text from that. So 0 scanned pages detected. The Scout classified all 294 pages as either digital text or art. This book has a pre-existing OCR text layer. Okay, then why has it taken 3 hours plus to OCR this document? I've never forced it to do so. I am, huh. Yeah, no shit. This reframes the whole picture. The current Dockling pipeline was spending 45 minutes doing neural OCR on a book that already had extractable text. Per page scout catches this in milliseconds. VLM becomes the fallback for books that genuinely need OCR, and even then, it's 2 to 7 times faster than Dockling server. For books with existing text layers, the pipeline is essentially instant. Want me to test a book that we know has truly scanned pages with no text layer to verify the VLM path also works perfect? Yes, I would like to fucking do that because I was unaware of that fact. So that means that either somebody's done a real faithful reproduction of this book to the point where, yeah, hmm, hmm. Okay, well, let me go see. Let me see. I need to find a book. I have no shortage of them. Just to, throw that out there. Let me see. Let me find one that has to be just. It has to be a really god awful copy here. Dark Side. No, no, that's Digital Born as well. That's for Pathfinder. Yeah, Legends and Lore. Legends and Lore. Yes. Okay. So this is Legends and Lore, which is very much you can see the scan line middle of the dock. This and you can actually, I think, if you zoom in enough, you can actually see the other side because you can see, yeah, you can see the page on the other side bleed through. So you're seeing this on the other side of the page. This has to be a PDF block. All right, so let me ask it to use this one, and I know I've used this one before in testing as well. So I'm going to copy this one. Copy. No, I don't want to copy the file name. I want to copy the whole goddamn doc into PDF ingest. It's already there. Oh, okay, stop. Um, take a look at the AD&D Legends and Lore PDF. That one definitely appears to be a scanned doc. Mm, yeah, I mean, I'm definitely not processing anything because my fans aren't on right now. So we'll see how far we get there. I'm actually, the more I use my MacBook, the more I'm impressed at the capabilities of this damn machine. I mean, I'm sitting here dual streaming 2K resolution to two different places, and I'm also running uh, multiple processes. Yeah, I'm just impressed. My other boxes, my Windows boxes, are not being able to do that. And if I could make Linux work on this, I would actually investigate doing so, but I don't want to just ruin things. Okay, check Scout results. So, did it find the doc I was looking for? Yes, yes, yes. Per page on ADB Legends and Lore. Okay. So, Darkly Tools Dockling. Yeah, there it is. All right, so I found it. All right. Legends and Lore PDF. All right. 130 pages classified as art, zero text, zero digital content. That's what I want. I want a pure scanned book with no OCR text layer at all. Okay, so perfect. This is exactly what I'm looking for. I've actually had this one fail because when it would see only images, it wouldn't do any kind of processing because it would just, it would try to scrape all the images, which is the entire document, instead of running OCR on this. It's actually failed a couple of times in earlier iterations on this. Okay, so 0 characters, 0 words, 1 image. 1 image being the JPEG or PDF, a PNG that was created inside the document itself. Right. Yes, classic flag. Scout correctly sees image coverage equals 1, character is 0. But the classification is wrong. These aren't art illustrations or scan text that need OCR. Fix when a page has high image coverage and 0 text. It's a scanned page that needs OCR, not art. Art pages and RPG books typically have some text, captions and titles, um, captions and titles, or are mixed in with text pages. A whole book of 100% image pages equals scan document. Yes. Let me update the classifier and rerun. So it's still figuring things out as it goes along, but I thought it had fixed this before. So I do make liberal use of beads memory and beads for work text options, but yeah, yes, it's a bit complicated. Actually, pretty good. My average time to render frames is also doing fairly well as well. So, of course, I could be not streaming this at all, and nobody's just paying. Nobody's able to pay attention. So, all right. Yep, that's exactly what I thought. Welcome to all my lurkers. So you know who you are. Uh, I'm glad you're here. So just to let you know. Uh, Rerun the first 10 pages of fixed classifier. Okay, so this is exactly what I wanted to do. So it found 10 pages, scanned 100%. The interesting thing is it's not going to be able to collect images within that. Is my guess. How it works, all 10 pages correctly classified as scan text VLN process. Each one individually is 6.5 seconds a page. That's impressive. That is super fucking impressive because this document I know was taking a very long time on the Darkly system previously. Very impressive. Per page processing works perfectly, memory stable. And I don't even have my fans didn't even come on. That's how good this is. 0 errors across 10 pages. Page 1 is a cover, 21 characters. 6, 10 are dense text pages at 10 seconds each. Now run the 130 page test at 6.5. That's 14 minutes, and memory will never accumulate. Okay, let's go do that. 6.5 seconds a page. That is damned impressive. So let's go do activity monitor, pull that up. I am interested in watching, let's see, CPU. So I've got Python 3.12. I thought I had 3.14. I'll have to go check that out. So I'm running at 102% of CPU. Memory, Docker is running at 40 gigs out of 64, which is would maybe, yeah. What? Okay, I know it's time to go downstairs. I'm testing something and I've got ones of people watching me. Do you want to get up here? You can get up here if you'd like. Come on, you get up here. There we go. Come on. My daughter's at summer camp being a counselor, so Overlord Mama Kitty knows that there is some kind of problem because somebody is missing. Come on, hey, come on. Yeah, get up here. Overlord Mama Kitty's like, why aren't you people more outraged at the fact that somebody isn't here? So, disk, launch D, Firefox nightly. So bytes written, 170, 300. Wow. MDS stores is at 310 gigs. Memory, okay, we're at 40 there. I'll run 130 pages. Yes, go ahead and do that with filtered output. I may do this. I may do this. The thing is, if it's not using metal at all, I might as well just stick it in Docker and just let it run that way. It'll report when done. Okay, well. You can see the output from Python here. So let's grab the processes. Oh, fan's coming on. Python. Okay, so it's got multiple Pythons here, multiple Pythons. I don't know if those are hung or what, but we'll see what's up with those as we go. Physical memory 64, memory use 52, 53, 52, 53, cached files 10, swap 3.4, 3.24 gigabytes. Wired memory. Okay, so we are swapping, but we don't have to worry about that like we did back in the day. Once you hit the swap file in Windows on your 5400 RPM, hard drive, things got slow real quick. So uh, that's good to know. The fan is running. What kind of energy are we pulling out on this thing here? All right, so we got OBS Studio is pulling 594. I'm actually impressed that Claude is hitting 4.4. All right, so we don't have anything crazy going on here. Oh, llama, there's a llama, okay. Because the quadrant and the chunking into quadrant was never an issue. It was always fairly fast that way. Running a full 130 pages. It probably would be fast. You know what? I bet if I pop this to high, I bet we can get it done a lot sooner. So I'm going to put this on high power. So we're going to see what happens. Either my system will overheat and die, which if I just randomly drop off, you'll know that my system crashed. And as you can hear, or not hear in this case, if you heard that hissing sound, that would be the sound of my fan going on, and it's actually causing me my privacy screen to flow up because of the way the ventilation works on a Mac. Um, I would turn on the air conditioner fan system that's underneath my MacBook, but that's not going to work. So uh, energy, okay, the energy just shot up here. Energy impact, yes. Memory, okay, memory is holding steady. That's interesting. So that is interesting. We're sitting idle at 67%. We're not even taxing the system right now. That's just how much this is working. So this is fantastic. If we could dump this directly to memory, we wouldn't have to worry about it on the Think Center. I mean, it would still run. I wouldn't use the VLM version of this. I would probably use, because there's two different versions of the Dockling 250 Elite. There's the Mac OS version for Silicon, as you see here. So no, wait. Word. Yeah. Local first. Yeah. So actually, I probably should have used MLX, multimodal image text to text model. So the MLX is the one that runs on. Um, this is the one I have running on the MacBook right now. They do have a non version of this that would run on something else that isn't. Well, let me ask the question. I wanted to recreate this ingestion system on a Intel-based system, Linux in this case. Would there be uh, would there would the lack of GPU and the use of the Granite Dockling 258 model not the MLX model cause a performance hit. Users taking MLX is, yes, I know, Apple Silicon specific. On Intel Linux, you'd see the Transformers version. Transformers version. Without a GPU, no CUDA. The Transformers model runs CPU only. The 258 million parameter model is small enough to run on CPU, but inference will be slower. I don't need an inference model. I need a ingestion model. Um, yes, performance hit without GPU, but model is small enough it's still viable. Here's the breakdown. Okay, so M4 Max, 6 to 9 pages measured, right? NVIDIA GPU, 2 to 4 seconds per page. Okay, so if I had a big ass CUDA, 30, even a 3090. I mean, I would imagine if I had a 5080 or something like that, this would be like a second a page, less than a second a page, maybe. Um, Intel, no GPU, 30, 60 seconds per page. God damn. Assuming you could do GGUF quantized, 15, so it's roughly half the speed that I've got here. So it would take half an hour to do a document heavy page like that. At 36 seconds per page on a CPU, 130 page scanned book would take 65 to 130 minutes. That's worse than your current dockling pipeline on Apple Silicon, but compared to dockling on CPU, which is also slow without a GPU. Okay. However, per page routing changes the math dramatically. So I wanted to buy like an eGPU um, extension. Yeah, that's a fucking thing. Okay, so wait, let's uh, see. eGPU closure. If I wanted to get something like this, which is a Thunderbolt 3 or 4 with a graphics card, and it comes with a dual display port and dual USB-C, probably 3 or 4 connectors that'll hold an NVIDIA or AMD chip down below here. Um, yeah, I could get that and then plug it into my computer. It won't work for the ThinkCenters because I think the ThinkCenters are probably 5 gigabit connections, but you need a some Thunderbolt 3 or 4 port on those. You would need something that's a little speedier. Um, yeah, compatible with NUCs, laptops, handhelds via Thunderbolt 3 or 4, USB 4. Optimized for DeepSeek. Yeah, I'm sure it's optimized for DeepSeek. There's some bullshit there. And AI deployment. Bullshit. Um, supports next gen, yeah, R50 series NVIDIA chips. Yeah, I mean, 5070, 5080, and the RX 7000 series. So yeah, I mean, you can definitely use this if you wanted to, but it's 189 bucks, and then that doesn't even include the cost of the GPU. So if I wanted even a 3090, so NVIDIA 3090, yeah, 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 it's 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 not a good time to buy even a cheap ass 3090. So I don't know if you followed me for any length of time. I had a streaming rig that I had bought here and used for about 6 months, and then was like, I had to replace the NVIDIA card in it because the 3060 that I had, for whatever reason, wouldn't work with the piece. What was that? It was some kind of pre-built PC computing bullshit pre-built company that built those out. Blue screen of death. Don't know why, but I ended up putting an RTX card in it, and it was stable as fuck after that. So there was something wrong with um, even after a rebuild or something. The CUDA NVIDIA cards did not play nice inside of that computer. Yeah, I'm assuming it has something to do with the BIOS because they had a custom BIOS and that shit. Um, but yeah, it's not a good time to try to buy video cards, right? And this is a renewed. This is a second hand card, and it's still $1,400 fucking dollars. Yeah, yeah. Other sellers. Let's see what their other options are. Okay, so Yeah. Yes. Very, very much. Yeah. AI's pooching it real good right now. And to be fair, I fucked up because I donated those to charity. So somebody's got a good deal, either using it for AI models or what have you. So, but that's okay. Bigger win on Linux, no Virtuo FS, exactly. The PyMu PDF Scout, 256, SHA hashing, file IO, all the things that are slowing your Mac due to Docker's desktop's VM boundary would be native speed on Linux. Orchestrator tick loop would never block. Yeah. Um, yeah, that's ideal. Yeah. Um, I really want to do. What I really want to do now is tear apart PDFs like the Planescape one and see um, if it truly has an OCR layer. I really do. That's something I want to try to futz with tonight. Um, yeah. The other thing I want to do is move to um, orb speed, orb. Damn it, what's it called? Docker implementation, orb, orb stack, orb stack. Yeah, looking to see if I can move to something like this. It runs everything. So my Docker Compose files will automatically work here. It's just the infrastructure and how everything is set up underneath is a little better. Um, Now, to be fair, I know I could run everything on bare metal, but I would really like to have it as much self-contained as possible for things like, well, I just would like to move things over to my Think Center that's running over here. I just want to download this Docker file, Docker run, Docker build, Docker complete, whatever, and make it happen without having to worry about those things or make those changes. So, um, yeah. The only bad thing is obviously I can't take advantage of the metal on OrbStack or Docker. So some things like the VLM or the XLM will still run on bare metal, but it's a small price to pay. There's an API. I can leverage the API through Docker to be able to access it directly. Everything runs in sockets or local. There's nothing connected to it directly. Um, uh, Tell me about some of the security aspects that we've had to implement when we moved to V3 of Darkly. And I realized the process of ripping this book would be a lot faster if I was not streaming uh, 2K and using up video memory for that, but it feels like it can handle it fairly well enough. So um, So a couple of the things that I had was like Quadrant was running so that it was accessible on the LAN, which is fine when I'm at home. But if I was connected to, say, I had to go into work for an on-site or I'm at a public Wi-Fi, my Quadrant is connected directly to the internet or to the local network, which is a no-no in my position. So yeah, capability isolation, Docker Compose grants, file mounts, but no Quadrant URL or Llama. Embedded workers get Quant URLs, but no file mounts or Docklink URLs. Um, Self-selection of work, that's right. Postgres durability, named volume, never a bind volume. Yeah, the file staleness, the file descriptor staleness that virtual IO is pretty much known for, I guess. I found that out after, I was doing more research. It was like, oh yeah, virtual IO goes stale, and it just dies. So the folder that I have locally where all my PDFs are stored, it just stops connecting to it, or the throughput to it is so slow that it just doesn't happen. Um, I'm trying to get, I did implement or did work to commit transactions to survive power loss. The idea would be if I'm on page 35, I don't want to lose 35 pages, which at the time it was like, 30 seconds a page or some shit like that. If this moves much faster, then the chances of me losing things due to things like power loss or whatever is lessened. And detecting silent crashes. So I've added a lot of logging, content integrity, so file hashes for deduplication as well, point IDs for upserts, quadrant verification, audit trails, so jobs assigned, starts, dones, embeddeds, a lot of logging there, which was very important to me because I needed to be able to get visibility into the system. So you can build that by just, a lot of try and accept things, different cases where, you can tell it to, print statements like now doing this. And it's like, well, if that happened, then print this. Otherwise, when the error code happens or when the exit code happens or, whenever codes happen, what does that mean and how do you solve for those? So a lot of what I was working on was trying to, accidental long running transactions holding locks. The idea is that the OCR portion is what takes the longest. And version 3, if we actually can use this model, is actually going to be the fastest version of this, which sounds great. I mean, there's no parallelization, but I can work on that. I mean, I could always run a couple of these, on both of my think centers. They're not going to be as fast, but I'll be processing, 2 or 3 in the time over here that I'm running 4 or 5 over here or something like that. Or I can put a bunch of them on think center and run it overnight. It's not going to be fast, but I'm not going to have to maintain it or watch it. So ideally, I'm trying for a more robust log system there. So, I think I'm going to go because kind of talking to myself here, but that's okay. I'm doing something that's interesting me. I'm doing a lot of work that isn't security related, but I mean, this could be drag and drop for anybody that might want to, process policy documents or something. I mean, there is definite real world use for this other than just, hey, I want to take a bunch of documents that have been purchased legitimately and, making inference searches on them. So, whether or not I decide I want to, make this available to people, I don't know yet. But I'm leaning towards no, only because I don't want to have people complaining when something doesn't work or doesn't work according to how they feel like. So this is my little project. I think one of the next things I'm looking at is maybe some sort of um, there is what. No, that's not it. So there's D&D Beyond, which is like a virtual tabletop thing. I just want to see if I can make one. Again, not a security feature, so it is what it is. But I want to do stuff that I like doing, and if I'm still interested in these things, I want to be able to do them. So I'm thinking I want to try something like Rust or do everything in Rust instead of Python because it does lean heavily, I've noticed, on Python for these things, and I don't know if that was because I told it to do that or if it just assumed everything should run on Python. I would like for it to try a different way or do something that's a bit more memory safe like C++, but I'm going to have to ask it to do a lot of garbage collection and take out the trash a lot. But Rust, do things that are memory safe, try to make it as secure as possible. Maybe I could create a dark lane Rust, that kind of thing. So anyway, oops, there I am. Oh, that's a pretty background. I like that. It's definitely a little busy. I won't lie to you, but that was the very first thing I created with AI was my background. I could probably make some changes to that as well. But I'm just trying to do something that interests me, and I won't tell you that it hasn't been kind of a pain in the ass sometimes, or like asking it questions like but it has that the ability for me to think critically, or like when I'm doing threat modeling, how could something go wrong? What's the problems with that? Has really come in handy for vibe coding or for building things because it makes me ask, well, what can go wrong? How are you going to do this? What if you do it this way? And what's important, I think, is making sure your AI or your LLM friend is not just a yes man. If you don't tell it to think critically, or now you've built this thing, now tell me how to secure it, or tell me how you would break it, or look for inconsistencies, or think critically. It's almost like it's got, I don't want to use the term schizophrenia or multiple personality disorder or whatever, but you almost have to have it step out of itself and then come back in and go, okay, you're a new person, assume the role of a security developer, solutions architect, or a senior security architect, and tell me how this architecture sucks, or what would you do to simplify it. It can and will do that. And what I love is that integrations like these are really nice to um, give you necessary information on how the system works, assuming you've done everything right, you've done your homework. So you can, look and see how everything functions in your system and ask you questions like, find idle workers and ready jobs, assign the job. Okay, who's doing that? What's doing that? Okay, PostgreSQL is doing, the orchestrator is going to Postgres and looking for the work or assigning a job. The orchestrator is notifying the worker over here for extraction. Then the worker is going to go back and read the assigned job and document flags from Postgres. Maybe there's too many, maybe this is too complicated. Maybe it needs to be simplified or something like that. But then it will post to the API. So you can actually look at these things and go, okay, what's doing that? Why is that doing that? Where's the logging on this? Where's the monitoring? So it's hatching the virtual, the hatch over virtual IO, or the PyMove PDF pre-scan page count is in the background scan thread or something like this. This will all change once I remove the VLM cruft. But yeah, I'm not sharing my screen. Anyway, the sequence diagram I was looking at earlier, you can go back and that. You can go back and look at the sequence diagram earlier, but using those sequence diagrams was really helpful to diagnose what's going on there. And to bring it back to a security event, you can ask your developers, if you're doing security reviews, give me a logical diagram, give me a sequence diagram that shows exactly how you use your freaking system. And you can ask them questions. It's like, okay, well, where are you inserting that in PostgreSQL? Or, what are you doing here? Or how are you making this thing happen? Or how are you logging this thing? You find logic flaws when you're looking at your diagrams. You can look at these things and go, okay, this is exactly how this system is going to work during the extraction phase or during this phase of your system. Or I think I asked the developer the other day, I was like, so what happens right here when you're uploading these files? It says it's uploading this, but who's getting notified of this or whatever? And it's like, oh, I'm exposing logic issues, or who has the ability to look at these things. If everybody has access to the same UI and you don't know that somebody's handling these jobs, you're going to have 5 different people who all got the same email are going to go to this site, and it's like, okay, how do you know this has been accepted? So you got 5 different people processing the same job. How are you coordinating that effort? So you can the logic diagrams, the sequence diagrams, the data flow diagrams are very helpful, not just from a security point of view, but from a user point of view, to help you understand where potential threats could be, or potential hangups or problems to the business. So anyway, I'm going to go. I really wanted to do the Socvel quiz, but I started geeking out over my stuff here. So I will get on probably Friday because my wife is going to be doing something that evening. So I'll get on. We'll do a Socvel quiz, and we'll talk about some real security stuff. I know some of you are probably like, oh, he's not doing security. He's boring now. That's okay. I'm doing what I'm interested in. Some of you hopefully are interested in some of this. And if you are building your own RAG, or you've got some other, you're not wanting to use a prepackaged RAG like a Studio LM or something like that, or you just really want to get into the nitty gritty of these things, we can chat. I'd love to chat about how you're doing it, or what you're doing to improve that. And I need to reach out to our good friend operator to make sure that I get him on. If not this weekend, sometime next week. I think he's out on holiday. So he's doing some really cool stuff as well, which really want to get him on and chat about that. So anyway, I'm going to go. Y'all take care. Be safe. And I love y'all, not, platonically, of course. I love my wife and my daughter and my cat, but Love you all. Keep on keeping on. Okay, talk soon. Bye.